Today's Daily Dose of Math is a pretend task for the MTH-3053 Secondary 3 Geometry course. A task is one of the big questions from the course where they don't tell you which technique to use. They ask you a question, they give you information, and you are required to figure out which techniques you've been studying will apply, and then apply them in a multi-step process to work your way to the final answer. Our situation is that I must surround 3 gardens with fence. How much fence do I need? Answer with an algebraic expression. I have diagrams of the 3 gardens. TUV is clearly a right triangle. There's enough information in the diagram to know that. LMNO is a rectangle. Again, there's enough information from the diagram to know that. PQRS, just looking at the diagram, looks like a square, but it could also be a rectangle that's just close to being a square. So it was necessary in the question to say it's a square, so the student knows what to do. The other information we have are algebraic expressions for the length and width of the rectangle, the fact that side PS of the square is equal to side TV in the triangle, the fact that the areas of the square and the rectangle are equal, and an algebraic expression for the area of the triangle. Because all the information we've been given is in the form of algebraic expressions, we can't solve for x in this situation, so we have to answer with an algebraic expression. Where will we start? I think the easiest place to start is rectangle LMNO because we know its length and its width. So I'm going to start by finding the area of rectangle LMNO. It's going to be equal to length times width, and that is 2x times 18x, which is 36x squared. I already know the area of the rectangle, which is going to be necessary to solve this problem, so I have started earning marks here. But I also need to know the perimeter of that rectangle because I'm surrounding gardens with fence, and that's perimeter. I have to know the perimeter of all 3 gardens and add them together to get my final answer. So I'll go ahead and find the perimeter of LMNO right away. It's going to be 2 times the length plus the width, which is 2 times 2x plus 18x, which is 2 times 20x, which is 40x. So we have an algebraic expression for the perimeter of the rectangle, and that's part of our final answer. And how much fence do we need? We have started earning marks here. Now we know that the areas of the rectangle and square are equal. So since the area of the rectangle is 36x squared, that has to be equal to the area of the square PQRS. The area formula of a square is A equals side length squared. So 36x squared is equal to side length squared. I'm going to square root both sides. The square root of s squared is s, so that's our side length. And the square root of 36x squared is 6x. We now know the side length of the square. We can find its perimeter right away because we need that for our final answer. The perimeter of the square has to be equal to 4 times that side length. So 4 times 6x, which is 24x. We need the 24x and the 40x to give our final answer. But we also need to know the perimeter of the triangle. One thing we know that was given is that the side length of the square is equal to side TV of the triangle, so we now know that side TV is also 6x. And we know the area of the triangle. So I have to do the area of a triangle formula backwards here. The area of a triangle is equal to base times height over 2. So in this case, the area 24x squared is equal to the base, I'll call 6x my base, times the height, which is going to be UV, that's unknown, over 2. There's more than one way to simplify this. But I'll start by just multiplying both sides by 2. And I get 48x squared on the left side is equal to 6x times uv. So the 2's have cancelled. I'll continue over here. 48x squared equals 6x times uv. I'm going to divide both sides by 6x. These cancel, and 48x squared divided by 6x is 8x. So our side uv is equal to 8x. I almost have enough information to find the perimeter of triangle TUV and give the final answer to the problem. I know side TV is 6x, and I now know side UV is 8x. I'm running out of room, so I'm going to do some erasing. I'm reproducing the answer to the perimeter of the rectangle because I'm going to need it in a subsequent step. Doing Pythagoras' theorem. Side TV is 6x, and that has to be squared. Side UV is 8x, and that also has to be squared. So Pythagoras has the shortest side squared plus the medium length side squared is equal to the hypotenuse squared. And the hypotenuse is side TU. 6x squared is 36x squared. 8x squared is 64x squared. These add together to give 100x squared. Now I square root both sides. The square root of 100x squared is 10x, and the square root of this is TU. So we have found that side TU is 10x units in length. Now we can find the perimeter of our triangle. The perimeter is going to be equal to the 6x that we found earlier in the problem, TV, plus the 8x that we found here for UV, plus the 10x that we just found with Pythagoras, and that gives us a total of 24x. We have to add that perimeter to the perimeters of the rectangle and the square. Rectangles here, the square was 24x, we found that here, and the triangle was also 24x, which we found here. The total is 88x. I want to apply a unit of measure, but none was given in the problem. So when that happens, I use the word units as my unit. 88x units is the final answer of this question. Now, what does a student have to be able to do to be able to answer a question like this? Let's look at some of these skills and techniques that you have to put together to work your way through this problem. We have to know how to use Pythagoras' theorem, and this is taught a lot in the book, plenty of emphasis and plenty of chances to practice it. We have to be able to do basic polynomial skills, like when we found the square root of 36x squared here, when we found the square root of 100x squared here, when we did this division, 48x squared divided by 6x. These are polynomial skills, and you have to be able to apply them when you need them in this course. We had to use the area formulas for all three of these shapes, and we also had to find the perimeters for all three of these shapes. Finally, and most importantly, we have to be able to read this question and understand it. All the information we need is given, but the question can seem quite intimidating at the beginning because it is long, it is a situation, and you don't have any of the answer yet. The key is to do what I did when I decided to work with the rectangle first, because I had a lot of information for that rectangle and it was something I knew I could do right away. Once you start doing something that you know will work, you start filling in information into the situation. And the more information you've filled in, the closer you get to the final answer, the less intimidating the problem seems. That is today's Daily Dose of Math. Please like, subscribe, and share.